Hello, and thank you for joining us today. Thank you for coming to our March webinar. Today we'll be talking about Sochi Games and how FileCatalyst was helping out with the Sochi Games. Today I have with me Chris Bailey. Chris is our CEO and co-founder and also my business partner. And I'm John Tkaczewski, the president. Hello, Chris.
Hey, guys. Thanks for joining us today.
So a lot of these topics that we talk about with the sports production or any other webinar we do monthly, we usually have a follow-up blog that we also do at the same time. So check out our blog if you have any questions or want to learn more about the topics we're presenting during the webinars. So for today, what we want to talk about is exactly what did we do with at Sochi Olympics and how FileCatalyst helped, and go through some of give you some just basic challenges with live sports production and where we can help out, and then go through the 3 different deployments that we did in February for the games. If you have any questions during our presentation, please type them into the GoToWebinar window, and we will go through them at the end of our presentation. So let's just go through the basics really quickly here, so everybody knows what we do. So one of the things we do is we provide accelerated file transfers. So what that means is that we can send a lot of data really fast over the wire. The network connectivity can be anywhere in the world. So that means if you have, one connection, let's say in Europe and one in North America, you'll be able to maximize the bandwidth and send the data at the maximum speed. We accomplish this by using our own protocol that is based on UDP. And unlike other protocols on the internet that are based on TCP, like FTP or HTTP, UDP is a much faster protocol. And we've built all the correction control and congestion control and all the tools to make sure that your files arrive intact while you're using our protocol. Our protocol allows you to always send files at the maximal bandwidth available to you, regardless of your network conditions. So as you're going further and further apart with the 2 points, the latency on your line will increase and all the TCP-based protocols will slow down. With FileCatalyst, they will always go at a maximum available speed. The nice part about this is that it allows us to control how much bandwidth we're using, and we can, make sure that we deliver everything on time and in good place without any corruptions. So let's talk a little bit about what sports production is going into. So there's a lot of talk on we've seen a lot of blogs about this, and we've seen a lot of articles that mention, the Olympics and about growth of at-home concepts. So this live event or the sports event is somewhere in the world, but all your production team is in your local studio, where your staff is working from the comfort of their own workstations and from the comfort of their own homes. Why is this possible? Well, first of all, a lot of the live major events these days have a centralized production team. So there's one production team that does all the camera work, that provides you all the feeds, and you as the rights holder for that event, you can concentrate on making stories and prepare programs. That's one thing. And on another side, there's also our planet is very well connected with networks. So these days you can get a 1 to 10 gigabit connection fairly easily almost anywhere around the world. So that makes it possible to connect that venue or that sports event quickly to your main office and or main studio, and then do everything from your studio. The problem is also that one of the problem is that right now what studios will do is they will build a studio at home, and then build a second studio exactly the same, but put it all in a container and ship it to the venue. And because there's so much equipment these days you can take to a venue, there's so much new technology, the amount of equipment and cartage that you got to pay for is becoming very expensive. And with the links and with the ability to with the internet with the network connectivity around the globe, and the fact that you're working with files now, you could do this much more efficiently from your main office. And once again, going back, that once you have that network connectivity, well, how do you get the data into your central studio? Well, you'll use your network, but there's still going to be that latency and the same issues that you would have that we usually solve with FileCatalyst with the accelerated protocol. So we will be able to we will allow you to maximize the bandwidth. So when you're sending the media files back to your central studio, everything's going at line speed. So some of the challenges that we've seen in the past, with the live sports production at the Olympics, video files, especially HD, can be very large. It could be 100 gigs or more, and it takes, even with very, very fast connections, it can take some time to transfer. The distance, especially when the games were in Sochi, and some of our clients were in North America, the distance was quite large, and the latency between the line was long, was very, very high. We were able to send the files, as fast as possible. The MXF standard, pretty much a lot of live sporting events these days use MXF files, and there's a very big difference between one MXF file to the other, especially how they grow and how they are handled. So that was one of the challenges that we've had with FileCatalyst, is to make sure that we handle the grow files properly in terms of how they grow and how they grow and how they are transferred over the wire. With Olympics especially, there's just a lot of content being sent. There's a lot of events going on at the same time, and all of these events have to be sent simultaneously. So just to give you a little bit more information on the MXF, Chris, can you walk us through some of the MXF issues we've seen, especially during the Olympics and with other clients that do sports production?
Sure. So what we've found is there's various different ways that the MXF container can be generated. We've seen where it grows from start to finish. So we see it growing to 1 meg, 2 meg, 3 meg sequentially, and it finishes growing and nothing else changes in the file, and that's what we call growing into the tail. We've also seen it growing from within, so we've seen MXF files grow to, say, 10 megabytes and then sit there for several seconds while the inside of that file starts to change. And then it will continue to grow and pre-allocate sections of the file and then change the contents of that section that's just allocated. We've also seen instances where after a file looks like it's completely grown, the essence is then written and the headers change inside of that file at various locations. Now, know that the MXF is not necessarily a standard, so there's different ways depending on which application or which vendor is generating these files, EVS or MOG or Avid. They're all creating files and they may have slightly different ways of generating the content. So we've had to adjust the FileCatalyst product to compensate for these different methods of MXF file changing. So what we've done is we've taken this partial, drawn a partial deployment for a sporting event, and we show you how you may have multiple events with multiple cameras on the left-hand side of the diagram. And what we've done in our FileCatalyst hot folder software is we've added the ability to kind of monitor this, start transferring. You can define number of workers or clients to be transferred, and it'll add new files as it sees them arrive. And even while it's transferring and all clients are busy, it can still monitor to see if anything new is added and if it's prioritized. It can also filter based on the file type. So if it sees MXF files, it can start to apply things like wait until the file is completely grown until it transfers it, or automatically turn on a progressive transfer. It'll start transferring the file as it's growing. It can delay for X number of seconds until the file has reached a certain size, or wait for a file to be static for up to 60 seconds before it decides that the file is completed, and that sort of thing. And then, of course, the files will be sent across the network to any type of a storage that you might have. harmonic or isolon, something like, or EMC. So this is just a diagram or a screenshot of our hot folder, or server rather, receiving dozens and dozens of files during the Olympics, just to show you the type of concurrency that we were dealing with some of our clients.
And I think this was actually, in a slow time, because all these some of these threads here were idle. I think at a busy time, right before prime time, all of these were lighting up.
Yeah, so during prime times, and we'll get into this a little bit more later, we would have up to 100 files that were transferring concurrently within the software. And they were all MXF files, growing and changing.
So let's talk a little bit about some of our deployments. As I mentioned, we've done a deployment with our partner MOG, where MOG has provided a tool, their MXF speed rail, to a central production team for the Olympics, and the central production team had two needs. They had to first deliver high resolution video files to the right holders, and second one to send the same high resolution files to the archive in Lausanne in Switzerland. So what we did, what MOG did here, they used the MXF speed rail as to power the workflow, and FileCatalyst was used to quickly move the digital content both to the broadcasters and to Lausanne. Bottom line is things were a bit faster and more reliable. For this deployment. Our second deployment for the Sochi Olympics was with a Russian broadcaster. We teamed up here with a partner named Koala Tron to service this Russian broadcaster. This broadcaster was specially created for the Olympics and to handle the Olympics for the Sochi Games. They will also be in existence for other events later on, Olympic events, but that was the main primary creation for this entity. And the broadcaster had 60 incoming feeds, and as well they had journalists and reporters out on the field with cameras pretty much at all the venues, creating stories and creating interviews and sending all this content. The content was all ingested to EVS, and everything was managed via EVS IP Director. So what happened is when those clips arrived, all the clips were logged, so they were very easily searchable. And then external clients could just go via the web, log in via the web, search for the right clips, preview them with Microsoft Silverlight, and once they were happy which clips they wanted, the clips could be all put together into a single video file, or they could be sent individually. And once the client has selected the clip they wanted to, those clips were then exported in the correct formats into the FileCatalyst direct server. And from there, there was a FileCatalyst 2-way Java applet on the website where those external clients could go in and download their clips. So once again here, the download process, we've simplified the process and made the, download faster and reduced the time, how much time it took the clips to download. So that was our second deployment. And here I'll just let Chris talk about a bit of our experience with NBC Sports.
Sure. So this was one of our bigger deployments for the Olympics, and as you know, the Olympics ran from the 7th to the 23rd, and we have a lot more details that we can give on the NBC story. We actually have a case study that we're presenting at the NAB show in Las Vegas if you want even more information. But the story was with them that back in the London Games, they started to see the feasibility of actually doing and taking that at-home approach with remote production. It was sort of a testing the waters period back then, and they actually decided to move forward. And they knew that they had several challenges. And back to what John was saying, there's so many events occurring at once, so many feeds. They have their own feeds that they're sending as well, and they're sending proxy videos back and forth for logging and editing. And so they knew that all this stuff was going to be going on, and they knew the type of concurrency they would need. They also had the additional challenge of being based in the U.S., so they have the high latency to Sochi, which really limits the speeds of any kind of an FTP transfer that they might have looked at doing. And then they had the massive concurrency, sending up to 100 files at a time. And they also had to deal with those files that they were sending were the MXF files being generated from the various vendors that they're working with, whether it be, like I said, EVS generating content, or Mog or Avid, spitting out those files. And they all had to be seamlessly sent back and forth with FileCatalyst. So this is just a sample deployment that we've drawn up to show you kind of what they looked like. So obviously based in the U.S. in Stamford, they had our FileCatalyst hot folder software running, pointing into back-end harmonic media grids. On the Sochi side in the IBC, they had our FileCatalyst servers deployed, again pointing at some media grids. And then at the various remote venues, they would have our hot folder software that were capturing any generated live feeds and sending them back into the IBC as well. So the process here would be you would actually have potentially 40 feeds coming into into Stamford. So we're downloading growing MXF files, 40 of them in that direction, and I believe that there's up to 40 in that direction. So then you'd have editors or loggers adding metadata to these proxies in real time, creating EDLs, which then get sent back across to generate the high resolution versions of those EDLs, and those then are sent back across to Stamford. And you also had the reverse in the other direction. You also had during the broadcasts or prior to the broadcast, they need to get archive footage back from the U.S. to Sochi. So they go into their tape archive, move archive footage from the tape archive to a media grid, and then be transferred across using FileCatalyst back to Sochi. So all of this combined, you would have up to 40 growing MXF proxy files that are transferred basically in real time. So they're around 5 megabits per second each. And they had to chase the tail, and as the file grows, they could be several hours being encoded, and they'd be across transferred by the time that they're actually done recording. And then you had the high res going concurrently. There could be up to 10 in each direction of the high res MXF files that are being going back and forth as well. And as John mentioned, those could be anywhere up to 80 or 100 gigabytes in size.
So this slide, I'm just keeping it here, so if you download it later, you can read about our company, what we do. But we basically are file transfer. We provide accelerated file transfers for the broadcast media and for the live sports. And here are some of our upcoming events. So we're going to be at NAB. We're actually going to have our own session at NAB called Accelerating Olympic Winter Games Footage from Sochi, Russia to Stamford, Connecticut. And Chris, I believe you're going to be speaking at that event?
Yep, I'll be speaking at that event, and we'll actually have Jim Miles, who's the director of production workflows there for NBC Sports. He'll be there as well, and we'll be speaking specifically about the NBC case and going a lot more in depth. And we'll have, like I said, the guys from NBC will be there to help answer questions about how was their experience and how everything went as well.
And we'll be also at Broadcast Asia in June, and then we're going to be off to IBC in Amsterdam in September. These are some of the shows. We might be adding more shows later on, but this is what we're scheduled for right now. If we have any questions, let me just check. We don't have any questions. I think we can, we don't have any questions at this point. So thank you very much for attending.
Well, and you I'll give you guys a couple minutes just if you have any questions, now is the time to ask them so we don't hang up on you too early.
And thank you very much for joining us, and goodbye.